So, how do we simplify rational expressions? That's our lesson today. Turn the page. A rational expression is. What's a rational expression?
Expression in simplest form.
Expression in simplest form. What is that?
What's the question? A ratio.
A ratio, okay. Give me more. What does simplest form mean? Say it again.
Can't be reduced.
It can't be reduced any further. So you're going to go down and you're going to type in an expression that can't be reduced any further. So it's going to take a little while to get used to typing on here. Here's the space button down here. And it's very hard for me to see the keys.
What was the answer?
An expression that can't be reduced any further.
Cheating.
Okay, so it's an expression that can't be reduced any. Okay, so simplest form, you can't reduce it any further. I want you to go to the next page and let's take a look at a few of these. Okay? All right, so we've got these first two, which are in simplest form. The reason we say that they're in simplest form is there's nothing we can do to make them look any different. Okay? This is the way they're going to stay. You can't factor anything out. You can't simplify anything. That's as low as it goes. Okay? The next three are not in simplest form. Right? X over x squared. How could I reduce that?
You do something with the exponent.
You do something with the exponents, yes. What do we do? When you divide variables, what do you do with their exponents? Subtract. So if this is x to the first power, that's x squared. What does it wind up becoming? 1 minus 2?
No, 1 x, right?
Yeah, you could either write it like this, x to the negative 1, or you could write it 1 over x. Remember that? This is the same thing as x over x times x. These cancel, which leaves you with 1 over x. Is it all coming back to you? No? Okay. I just want you to see a couple examples of something that's not simplified. This is what we call a complex fraction, the second one. Okay? We're going to be working with complex fractions next week. And this third one, what cancels?
X minus 3.
Yeah. X minus 3 over x minus 3 equals 1. So we can simplify that to 1. They cancel out, and we're left with 2/3. Okay? So these are not in simplest forms because they can be changed. They can be simplified. What'd you say, Alfred?
With the second one, you just get rid of the 1.
You would keep change flip.
Keep change.
Yeah, because a fraction is just division. So we'll be dealing with that next week. Okay? All right, go to the next page. All right, so example 1, simplifying rational expressions. We're going to work on simplifying this, okay? The mindset you need to get into is factoring. You guys remember how to factor? We're going back to 9th grade here. Did you do any factoring last year? A little bit?
Question.
Okay, so what you're going to do is you are going to scroll down and over so that you are at the very end. Once you can't go any further, you're going to hit enter to get down to the next line. We're going to type all of this right in our calculators, okay? So this, from here on out, calculators, we're not doing it on paper anymore. Are you ready? All right, who remembers how to put in a fraction?
Control divide.
Very good. Control, divide is going to give you your fraction template. So we're going to be able to type right into this, okay? All right, so let's look at the numerator. X squared plus 10x plus 25. I need two numbers that multiply to be a positive 25 and add to be a positive 10. What are my numbers?
5 and 5.
5 and 5. So this factors 2. You're going to open your set of parentheses. You're going to do x plus 5. Notice it already closes it for you, right? Hit your over arrow. Open another set of parentheses. x plus 5. Was everyone able to do that?
Uh-oh.
Perry, you struggling? You're not Perry. Your first name's too long. Demetrius. You got it?
No, it keeps on going down. It doesn't go over.
All right, so go down to get to the bottom. Just hit your down arrow on your napkin. It's going to bring you to your denominator. We've got x squared plus 9x plus 20. Two numbers that multiply to be 20 and add to be 9. 4 and 5. So you're going to do x plus 4, x plus 5. So open your parentheses. X plus 4. Open parentheses, x plus 5. Is everyone able to do that? Yeah? Okay, so now go right to the end of it so that you're out of the little box that it gives you. What you're going to do is you're going to hit your equal sign. Equal sign is right diagonal to your control key. Put in another fraction template. And let's look at what happens between the numerator and the denominator. Do you see anything that's going to cancel?
5 plus 5.
Your x plus 5s, right? So what are we going to be left with? Good, put it in. X plus 5 over x plus 4. You don't have to put the parentheses once you've simplified it. I have a tendency to do that because it's just the way my brain works. You don't have to do that. So that's simplifying a rational expression. How we do? Not too bad, right? Does get a little bit tougher. But we need to get comfortable with this. All right, does everybody have this in? Okay, go to the next page. All right, so page 1.5 is what you should be on. You're going to try these. You can do them on your paper. If you feel comfortable enough, you can add pages and put them right in your calculator. It's up to you. Okay? But I want you working with your partner next to you and talking through these. So if you get stuck, raise your hand and I'll come over and help you. I'll give you a few minutes to do these. We're going to talk about number 1. Okay? This first one, you notice we're not going to factor like we factored the last one. This one is more division. Okay? It's not as hard as it looks. You just need to think differently. Negative 27 divided by 9. Negative 3. X cubed divided by x to the 4.
X negative exponent 1.
X to the negative 1. So remember, we subtract the exponents. Y divided by y. How many times does y go into y? Once. Do I need to write a 1? No. So that's your answer for the first one. How many of you got this right? Okay, the other way you could have written this, negative 3 over x, that also works for me. Same exact thing, written a different way. Okay? All right, number 2 is where I seem to see you guys getting tricked up. You're not having any problems with the denominator. Okay, how do I factor that? X minus 4, x minus 2. Do we all get that part correct? This sign is a plus. It means the signs are the same, and it's whatever's here. All right, so the numerator is where I see you guys having trouble. This is a GCF, okay, greatest common factor. Give me a number that can be divided into negative 6 and negative 3. Yeah, 3. All right, so if I decide to pull out a 3, factor out a 3, I now have to get what's left here. This piece right here is division. So if you want to know what goes inside, you divide by 3. Okay? Negative 6 divided by 3 is negative 2. Negative 3 divided by 3 is negative 1. So there's your piece. Is negative 2 minus x the same thing as x minus 2? No. Can you cancel it? No. Leave it the way it is. That's it. How do we do on the third one?
I just forgot the fact
Forgot how to factor the top one. Okay, so my hint to you guys is to start with what's easiest. Is the numerator or the denominator easier? Denominator. Okay, so somebody tell me how you factor.
Twice you get 6 and then Add to get -5.
Okay, so what are your factors?
X minus 3 and X minus 2.
Good, x minus 3, x minus 2. Good. Okay, so that part was easy to find. Now we're dealing with the numerator. We know that we have to have a 2x, and we know that we have to have an x, right? We all started off that way. So I need two numbers that are going to multiply to be 2. Well, what are my options? What are my factors of 2? Yeah, I have to be dealing with 2 and 1. I just need to know where I'm going to put them, okay? So when we're dealing with something like this, chances are we're going to get something to cancel. Am I going to get this to cancel? No, because my factors don't involve 3. So I want this piece to cancel, the x minus 2. So chances are this is x minus 2. So what's this piece have to be? Plus 1. What do we get to cancel? And I'm left with 2x plus 1 over x minus 3. Okay? So sometimes you have to think about things differently. You have to be comfortable with factoring. The whole next week is going to be factoring. Because we're going to do simplifying, adding, subtracting, multiplying, dividing, and then complex fractions. So you have to know how to factor. Okay? Can anybody get that third one right?
I can get to it.
We got some work to do, huh, guys? All right. Let's look at the next page. Okay, so when is this ever going to be used? We're dealing with architecture. How many of you, do I have anybody in here that wants to be an architect? No? Okay. Well, this is used for architecture, okay? So we're going to look at how to do this with architecture. All right, one factor in designing a structure is the need to maximize the volume, which is the space for working, for a given surface area. Compare the ratio of the volume to the surface area of a cylinder with radius r and height r to a cylinder with radius r and height 2r. Okay, so that was a lot of talk. Let's look at how we actually do it. Go to the next page. Now, last year you were given these formulas. This year you are not. So you need to know them. Okay? Use the formulas for volume and surface area of a cylinder. How do we find volume of a cylinder? You're going to type it in, so get down there. Volume of a cylinder. Anybody?
I forgot. So don't you have to do the volume of the circle? Or the area of a circle and something else?
And then multiply by the height.
Good. Pi r squared h. So here's your pi key, right down here. And then you're literally going to put r, and then squared. Did you guys get this happening? Okay, just what I did is I just put in an r, and then went back and deleted out the other one. Pi r squared h. Okay. Okay, surface area. Anybody remember? Expression it. 2 pi r h plus 2 pi r squared. Okay, so if you get stuck and it comes up again, you can hit that x squared button first and then put in the r. It works better that way. Do you want me to show you how to do that again? Did everybody see it? You got it? Okay, so there's your two formulas, right? So now what are we going to do with them? Go to the next page. All right, so we're going to look at a cylinder with height r. What we're going to do is we're going to divide the volume formula by the surface area formula. So you're going to go right down here, and we're going to put in a fraction template. Who remembers how to do that? Control division, good. Got our fraction template. What was the volume formula?
Pi r squared.
Pi r squared h. So pi r squared h. Surface area formula?
2 pi r h
2 pi RH plus 2 pi r squared. Okay. All right, so I'm going to give you guys a minute to figure out how to factor this correctly. I'm going to put in an equal sign because we're going to have more off of this. Okay. So I want you to look at this denominator, and I want you to think GCF. What does this denominator have in common? What do the two pieces have in common? What do they have?
pi squared.
Oh, I'm sorry. Thank you. My fault here. Should be fired immediately. How's that? Better?
Public, negative.
Good? Did I do it up top too? I am terrible. Somebody else did it too, so it's not just me?
It works now if you put R and then the square button.
Of course it does.
Yeah.
Okay. Okay, now we're okay. All right, so I want you to think about the denominator. What's the GCF? What do they have in common?
2
A 2, what else?
Pi.
A pi and a r. So you're going to pull out a 2 pi r. So you're going to factor this. I'm going to give you a minute to try this. So the first thing I'm going to do is I'm going to put in a fraction template. I'm assuming we all got that part, right? We know we can't factor the numerator, so I'm just going to put back in what I had. That was not what I had. Pi r squared h. And what we factored out in the denominator we said was going to be 2 pi r, correct? That was our GCF? Okay, so now we're going to put in an open parentheses. If I factored out a 2 pi r, what's left with this first piece here? Just an h. Okay, so what's going to be left here? Just an r. Did we get this far? All right. Let's go to the end. Put another equal sign. Put another fraction template. All right, so we've got pi r squared h, 2 pi r, h plus r. Okay? I want you to look at what we factored out and what's in the numerator. What can we cancel?
R.
We can cancel 1 r. What else?
1 I.
And 1 pi. If we cancel 1 r and 1 pi, what's that going to leave me with in the numerator? RH. So in the numerator, you're going to put RH. Okay, we got rid of a pi and we got rid of an r. What does that leave us in the denominator?
Pi HR.
2 times h plus r. Now do we see it? Is that better? Is there anything else we can do here? No, because remember, if it's in a set of parentheses and it's being added or subtracted, you can't just cancel. Okay, it's got to be a factor. Can you see it now? Are we good? This takes a little getting used to. Okay? All right, go to the next page. Okay, we're going to try the same thing, except this time we're dealing with a cylinder with height 2r. Okay? So before we had h, instead of h, we're going to have 2r in there. So you're going to put right in, go right down to here, put in a fraction template. Are all getting used to hitting these keys now? A little bit better?
And then for the H, we substitute 2R.
Good, so you're going to put pi r squared 2r. That's not enough. So instead of the h, we have the 2r. Go down, plug in, 2 pi r, 2r. Plus 2 pi r squared. Okay, do we have this? All right, I want you to look at the numerator. I have pi times r squared times 2r. Can I simplify that? Combine things?
Yeah, the 2r.
What's r squared times 2r? What's r times r?
2r.
R squared. What's r squared times r? R cubed. So what you're going to put here is we're going to put 2 pi r cubed. You guys remember how to put in higher exponent? Caret, good. 2 pi r cubed, good. Okay, likewise, 2 pi r times 2r. How are we going to simplify this first piece?
It would be 2 pi r cubed.
2 times 2? R times r. 4 pi r squared.
Oh.
Do I have to do anything to the second half of that denominator? So just put it back in the way it was.
I thought that's how you got the 4.
Nope. See here? 2 and 2. 2 times 2 is...
Oh. I thought you did
Addition. You can only add them if they're like terms. In the way it looks now, you can. All right, so look at the denominator. I have 4 pi r squared plus 2 pi r squared. What is that?
6.
6 pi r squared. So redo your numerator, write 6 pi r squared for the denominator. How are we?
And we're to the next page.
Went to the next page?
For the next
Yeah, that's fine. It's okay. Which means maybe you put a couple spaces or something in and I didn't. Okay, so can we simplify this? 2 over 6? What's 2 over 6 simplified to? 1 over 3. Pi over pi?
Cancels.
Cancels. R cubed over r? R. Where's that r going to go? Where's the 3 going to go? So what's your answer?
So r 3.
R over 3. That's your answer. Is it all coming back to you now?
No.
9th grade algebra? It's not coming back to you yet?
We had like 3 teachers in 9th grade. So
You had like 3 teachers in 9th grade?
yeah. We had one that quit before it, then we had Mr. Higgins, and then we had Papa Bliss.
Okay, well,
So we just had a whole thing of winners.
next page. Now remember, since we put all this work in, we're going to do what, Alfred? At the end.
We're gonna say.
We're going to save it. Okay, just making sure we remember. All right, so good. Now on your paper, I'd like to find the ratio of the volume to the surface area of a cylinder whose side is 4r. I'm going to skip that part. We're going to move on from there, okay? We are going to look at the next page. We're going to skip that page. All right. I want to look at multiplying now because this is going to give us the same sort of practices we were doing with simplifying. We're just going to take it one step further, okay? All right, what I want to do is I want to know how we multiply 2 rational expressions. And what I'm going to have you do is I'm going to have you write down the steps. So I'm going to have you add a notes page. You guys remember how to add a notes page? Control I, good. And you're going to add notes. Okay? So what that last page asks you to do is it asks you how you would proceed to multiply this, okay? So I'm going to have you put in step 1. The first thing that we're going to do is we're going to factor everything that we possibly can. So I'm going to have you write factor everything. Okay, does everybody have that in? Okay, after you factor everything, what was our next step when we were simplifying? What did we do? We factored everything and then we did what? We simplified or canceled out the same factors, right? So the next thing you're going to say is you can say simplify if you want to say it as cancel because that's how you remember it. That works for me. Okay? So cancel, equal factors, or simplify. Okay? Now, if you simplify and you factor correctly, you won't have to simplify again. Okay? You may have to if you forgot to factor something specific. All right, so step 3, after we've factored and we've simplified, how do we multiply fractions? Nope, that's adding and subtracting. When we multiply fractions, we multiply straight across. Okay? So I want you to write multiply the fractions, and you multiply numerator by numerator, denominator by denominator. So multiply straight across. Okay, so you're going to multiply straight across the numerators and the denominators. Now when we cancel, remember you can cancel up and down, and you can cancel diagonally. You'll see that in just a minute. So everybody have it typed in? Almost. I see still fingers are going. Okay, so let's look at the next page. We're going to do this right in the calculator. We're not even going to do it on paper. I think we're good enough to get used to this. Okay, so what we're going to do is you're going to scroll to the end, put in an equal sign. And we are going to start factoring. Okay, so put in a fraction template. Let's look at the numerator of the first fraction. X squared minus 4. This is what we call difference of two perfect squares. You guys remember how to do that? Give me two numbers that multiply to be -4 and add up to be 0. -2 and 2. So we're going to have x plus 2, x minus 2. Very good. Good.
X or A?
X. A. Thank you, Edith. A. I guess I just got a little carried away with my X's. X. A. Okay. What about the denominator? How do I factor that? Give me two numbers that multiply to be -1.
-1.
-1 and 1. Do they add up to be 0? Yeah. Okay, so A plus 1, A minus 1. Okay. I just hit the multiplication key. That's going to give me that little star there. And put another fraction template in. All right, so let's look at the second fraction. Anything I can do in the numerator? No. So just put back in A plus 1. I put it in parentheses. You don't have to. I prefer to. I think it makes it easier to see. Okay. Look at the denominator. GCF? What can I pull out? What do they have in common? A. Just take an A. Make your set of parentheses. What's going to go in those parentheses? A plus 2. Very good. Good. How are we doing? All right, so we've got that all factored. Our next step after factoring would be to cancel stuff out, right? Simplify it. Put another equal sign. I'm going to go down to the next line. so we can continue straight across. Put in your fraction template. What do you see that's going to cancel?
A.
I'm going to cross it out so you can see it. What factors do we have in common? A plus 1 and A plus 2. Okay? You have to cancel the whole factor. You can't just cancel a piece of it. All right, so A plus 1s are canceled, A plus 2s are canceled, and I'm left with what?
A parentheses A plus 1.
We have A minus 2 in the numerator, and in the denominator, A parentheses A minus 1. A times A minus 1. Perfect. So that's exactly what you're going to put in the next fraction. Okay? So we have A minus 2. That's not a minus. And in the denominator, you're putting exactly what you're left with. A times A minus 1. That's your answer. I want to talk about one more thing with this. Notice it says to state any restrictions. Restrictions mean something that we can't have happen. Okay? So I want you to look at the denominator. There's something very important in math that we deal with when it comes to fractions and denominators. Something that can never happen. What is that? What can we never have in a denominator of a fraction?
0.
A 0. Why can't we have a 0 in a denominator? What happens to my fraction? What do we call it? Undefined. Good. So I want to know my restrictions. What can't A be?
0.
Okay, so A, and you're going to have control equals. That gives me a not equals. Okay, control equal gives me my not equal. A cannot equal 0. I have a comma. I just have to find it. Here. Or, say it again. Or 1. Why can't it equal 1?
Doesn't make it 0.
Yeah, it's going to make this be 0. Comma's right here, diagonal to the plus sign and the enter. Is that what you're asking how to do?
No,
Not equals?
yeah.
Control equal. Okay? So it's important that you state restrictions. This becomes very important when you guys do pre-calc next year. All right, so A cannot equal 0 or 1. Make sense? Okay, let's look at the next page. All right, so now that we've mastered multiplication, let's try division.
We've really mastered it.
We will master it. We're going to do lots of practice. All right, so when we divide fractions, you have to, if I want to divide 2 fractions, I have to do what? Who remembers the saying?
Keep change. Or
Keep,
add,
change,
flip.
flip. So write that down. I want you to put it in all capital letters. Who knows how to make things capital?
Control.
Control caps. Keep, change, flip. Keep, change, flip. You remember this? Barely? A little bit? You remember keep, change, change? Okay, I say keep, change, flip. Okay. Everybody have that in? Let's look at the next page. All right, so when we divide rational expressions, we have to remember to state any, not Andy. State any restrictions. This doesn't have spell check on it, and like I reminded you at the beginning of the year, I'm a very poor speller, so I apologize. All right, so I want to divide these 2 rational expressions. Notice I was so kind to already factor them for you. You can thank me now. Thank you. You're welcome. Okay, so what we're going to do is we're just going to write down how we're going to follow through with this expression, okay? So I want you to go up. You're going to put in your equal sign to enter to go down to the next line. So I put an equal sign at the end. I went down to the next line. Okay? Fraction template. You're going to write the first expression exactly as you see it. So 4 minus x over 3x plus 2, not cosine, x minus 2. Okay, if this is division, here's our keep part. We just did our keep. Change means you're going to change division to multiplication. And flip means you're going to flip that second fraction. I still have my caps lock on, don't I? Don't forget to turn off the caps lock. Okay. Oops. Okay, so divide. You're going to do what?
We're gonna keep.
You're going to keep. Then what?
Change.
Change, and then flip. So I'm going to give you a few minutes to keep, change, flip, factor, 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 simplify, 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 multiply. Okay, so it's the same exact thing as multiplication. You're just adding one more step. You're flipping that second fraction. All right, so take a few minutes to do that. That's what you should have gotten. How did we do? A little bit better than the first one we did?
Still not getting when to keep changing. Flip.
You keep, change, flip only if it's asking you to divide.
Only.
Only if it's division, yep.
Oh.
Keep, change, flip for division. For multiplication, you just keep it the way it is, factor it, simplify, and multiply. All right, so you have homework, lesson 2, right on your calculators. All right, that'll be due next class. Your weekly project, again, due Tuesday, Monday next week, sorry.
How do
All
I
right.
save all this again?
Now, to save, are you ready? Control, home. Simply click the file, 3 is saved. That'll save it for you. The other way you can save it is just hit Control S, that also saves it. Just like on the computer.
Will we have names on the tests and quizzes, or?
When you guys take a test or a quiz, I will do press to test, which means you won't be allowed to get to any of your documents.
Oh.
Okay?